forget about the older part of the geology. And when we are talking about an expedition or the mission to Mars, mission to Moon, or many other planets, do we really know about the entire Earth? Or what are the reasons why we are not giving much importance to this entire Earth? And how this, when we start physics of the Earth uh, or planetary geology, we have to think more about the early part of the Earth. Not even early. If I say early, then I can say Haddon is the early part of the Earth. But a major part of the Earth is Archean and Proterozoic. That we can calculate 87% of the Earth. We are just learning little about this Earth. Now, why do we need to know about the early Earth? For referencing something. Means if you look at the concept of scale, when the earliest scale was developed, the question behind the mind of the scientist or the whoever proposed the earliest scale, what should be the reference? They used to call feet. So people used to have feet as the reference. But feet in what reference? Feet it is there. What is the scale? So this referencing is also essential for large part of the earth material. If we say mantle, then mantle is evolving. Mantle has evolved for last 4,000 million years. Mantle evolved means composition of the mantle, temperature, viscosity, density, everything evolved. So what is that starting point from which we have to begin the evolution? What was the composition of the original mantle with reference to the modern mantle? So you need some reference point. Same thing, atmosphere. We know the modern atmosphere, but atmosphere is evolved for so many millions of years. For 3,000 million years, atmosphere has evolved. Earlier there was no oxygen, lot of nitrogen, lot of CO2, lot of sulfur. So why and how this composition evolved to the extent that we are studying, we are looking at this in a modern state? How the temperatures were evolved. The early Earth surface temperature itself were of the order of 200 degrees centigrade. The cosmos temperature, the universe temperature of the universe is about 270 degree presently. But maybe it was very, very hot. So how these temperatures evolved on Earth and what is its relation to the cosmology, that has to be understood. The fundamental knowledge has to be understood. The composition of rocks. Forget about rocks. The composition of the matter. How the periodic table evolved. How these different elements in the periodic table evolved. Why immediately so many elements we are finding on Earth. How this each and every element, their atomic structure evolved. You have to know the early Earth. And not only early Earth, but before the early Earth, the formation of the solar system. Before that, nucleosynthesis, how the periodic table evolved. You have to know a lot about the nucleosynthesis, how the atoms evolved from the earliest atoms of hydrogen and helium. So many different elements were evolved. Radioactive, stable, or many rare earth, all these elements, how they evolved. The answer is in the understanding of the cosmology or understanding of the universe. That means we cannot marginalize the Earth's history with just a beginning of the Earth, just formation of the Earth, or just last 500 million years. We have to learn a lot. We have to learn about the early 4,000 million years. Before that, we have to learn about the evolution of the solar system. Before that, you have to learn about the formation of the universe, more than 13 billion years. So like that, there is no end to the science. And why we are sticking only to the 500 billion years, there is no reason. We have to learn about the early cosmology or early Earth and its link to the cosmology in order to evaluate the sustainability of the Earth. If we say that Earth is evolving, what is the course of evolution? What should be another 5 million years from present? What should be there another 10 million years from present? But let us not go 5 million years and 10 million years are big things. People are not interested. What is going to happen next 500 years, 1000 years? Also, you have to know about the early Earth, how the course of evolution of the Earth, how the Earth is evolving. We cannot say, we cannot really imagine about the evolution of the Earth unless we start from the beginning of the Earth. And if you want to know more detail, then unless we start from the beginning of the solar system, then you go into more details. So to understand anything, as I said, understand the origin of atmosphere, understand the origin of life and how the life evolved. It is not simply the organic compounds evolved, but the earth processes were involved in the evolution of the life. Without that, there was no question of evolution of the life. The geological timescale lasts 500 million years. We are talking about how this geological timescale is evolved or constructed. It is simply based on the evolution of the life, appearance of different biota, extinction of different biota, and their zonation, and that's how we got this entire geological time, not entire geological time scale, at the last 540 million years. If you look at the foundation or fundamentals, why and how this geological time scale is created, these fundamentals and foundation or rules are applicable only for the 540 million years. Why? Because these 540 million years are classified or constructed based on the biotic changes. And before that, one may say that early life was there during the Archean, but that life is discounted in the, you cannot classify based on that life any geological time scale. So what is the criteria for geological time scale before 540 million years is entirely different than after 540 million years. So this contradiction is there within the geological time scale only because we know very little about the early Earth. And another thing is that we cannot apply same rule for the later than early Earth. We cannot apply the same kind of plate tectonics for Archean and Haydn kind of plate tectonics, Archean and Haydn kind of tectonics that we will see later on in the next semester. Maybe in March we have to start next semester also. So I leave it for that part. So there is a major difference between the early Earth and, in a very casual manner, I can say, for time being, I can say the early Earth in our mind is older than 540 million years, which includes a very large part Haydn, Archean and Proterozoic. And if we want to learn about this early Earth, then we have to learn about the origin of the Earth. Then if we want to learn about the origin of the Earth, then everything goes into cosmology and so many other things. And the textbooks and all these things, they give a perception that the geological processes in the early Earth were very dynamic.